Hi everyone, I'm making this video for the people who don't have this handbook, Hariyanth Chemistry Handbook. So I may not explain the concepts exactly, but I'll just read the chapter and please just listen to that what I read. So the people who don't have this book may revise their concepts just by listening. So the chapter today which I'm going to start is chemistry in everyday life. The page number is 480. You can just you put your earphones and just listen to what I say so that your concepts may revise easily. Okay, the topic is chemistry in everyday life. Medicines or drugs. Chemicals which may be used for the treatment of diseases and for reducing the suffering from pain are called medicines or drugs. The branch of science which makes use of chemicals for the treatment of diseases, therapeutic effect, is called chemotherapy. Some important classes of drugs are antacids, the chemical substances which neutralize the excess acid in gastric juice and raise the pH to an appropriate level in stomach are called antacids. The most commonly used antacids are weak bases such as sodium bicarbonate, sodium hydrogen carbonate, NaHCO3, magnesium hydroxide MgOH2, and aluminium hydroxide AlOH3. Generally, liquid antacids are more effective than tablets because they have more surface area available for interaction and neutralization of acid. Milk is a weak antacid. Histamine simulates the secretion of pepsin and hydrochloric acid. The drug cimetidine, Tegamet, was designed to prevent the interaction of histamine with the receptors present in the stomach wall. Cimetidine binds to the receptors that triggers the release of acid into the stomach. This results in release of lesser amount of acid. Now, ranitidine, Zantac, omeprazole and lansoprazole are used for hyperacids. I am making this video for the people who are lazy to read the book. So they can just put the earphones or headphones and listen to the video. That's it. And the next topic is tranquilizers. Psychotherapeutic drugs. Chemical substances used for the treatment of stress, anxiety, irritability, and mild or even some mental diseases are known as tranquilizers. These affect the central nervous system and induce sleep for the patients as well as eliminate the symptoms of emotional distress. They are commonly constituents of sleeping pills. So the next is noradrenaline is one of the neurotransmitter that plays a role in mood changes. If the level of noradrenaline is low, the signal sending activity becomes low and the person suffers from depression. In such situations, antidepressant drugs are required. These drugs inhibit the enzymes which catalyze the degradation of noradrenaline. If the enzyme is inhibited, this important neurotransmitter is slowly metabolized and can activate its receptor for longer periods of time, thus counteracting the effect of depression. Iprosenide and phenelzine are such true drugs. So these two are the important drugs. That's why I underlined it. Please note it down. And the next topic is barbituric acid and its derivatives. Vernol, ametyl, nembutal, luminal, seconal are known as barbiturates. Barbiturates are hypotonic sleep producing agents. This is the example of barbituric acid, luminal, vernol. Equinol is used to control depression and hypertension. Non-hypotonic chlorodiazoxide and meprobamate are relatively mild tranquilizers suitable for relieving tension. So these two are the important drugs which are suitable for relieving tension. Please note it down. You have to just go through the examples properly in the mains or advance or whatever my the exam MSET or any entrance exam, they never ask what is tranquilizer, but they only ask the examples. The examples are very much important. So next is analgesics. Medicines used for getting relief from pain are called analgesics. These are two types. Narcotic. Drugs which produce sleep and unconsciousness are called narcotics. These are habit forming drugs. For example, morphine and codeine. Morphine diacetate is commonly known as heroin. Non-narcotic. These are non-habit forming chemicals which reduce mild to moderate pain such as headache, toothache, muscle and joint pain, etc. These are also termed as non-addictive. These drugs do not produce sleep and unconsciousness. Aspirin, 2-acetobenzoic acid, is most commonly used analgesics which antipyretic properties. Now these days, because of its anti-blood clotting action, aspirin is widely used to prevent heart attack. So this is the example of aspirin. Please note it down. Aspirin is toxic for liver and sometimes also causes bleeding from stomach. So, naproxen, ibuprofen, paracetamol, dichloromethane sodium are other widely used analgesics. The next topic is antipyretics. These are the chemical substances which reduce body temperature during high fever. Paracetamol, aspirin, phenacetin, 4-hydroxy acetylidine, Analgin and Novalgin, etc., are common antipyretics. Out of this, paracetamol, 4-acetaminophenol, is most common. So this is the example of paracetamol. Please note it down. The next topic is antimicrobials. An antimicrobial tends to kill or prevent development of microbes or inhibit the pathogenic action of microbes such as bacteria, fungi and virus selectively. So these from here to here is the important point. So I guess these are the important. Sulfa drug constituent a group of drugs which are derivatives of sulfonamide and have great antibacterial capacity, microbial sorry. Thus these are widely used against diseases such as diphtheria, tuberculosis, etc. and dysentery. So this drug is used for three diseases mainly. And these are the examples: sulfonamide, sulfadiazine, and sulfapyridine, sulfaguidine, sulfadamidine. In structure, these drugs are analogics of p-aminobenzoic acid. Different types of antimicrobial drugs are as follows. So these are antibiotics. These are the substances produced wholly or partially by chemical synthesis, which is low concentrations inhibit the growth of microorganisms or destroy them by intervening in their metabolic processes. Antibiotics are products of microbial growth and thus antibiotic therapy has been likened to setting one thief against another. Antibiotics are two types. Bactericidal antibiotics have cidal killing effect on microbes. For example, penicillin, ofloxacin, aminoglycosides, etc. So these are the important examples we have to remember: penicillin, ofloxacin, and aminoglycosides. Bacteriostatic antibiotics have a static inhibitory effect on microbes. For example, erythromycin, tetracycline, chloramphenol. So these are the three examples. So they also gave a separate box for penicillin. Was the first antibiotic discovered by Alexander Fleming in 1929, and this is not so important for the exam, so that's why I'm skipping. And don't think anything else, but I'm just skipping this box because it is not important for the exam. In the revision process, this is not needed. Next, broad spectrum antibiotics, also called wide spectrum antibiotics, are antibiotics which are effective against several different types of harmful microorganisms. Example, tetracycline chloramphenol phenol given in case of thyroid, dysentery, fever, etc., ofloxacin, etc. So these are broad spectrum antibiotics. And now antiseptics. These are the chemicals which either kill or prevent the growth of microorganisms. Antiseptics are applied to the living tissue, so these are only applied on, it is used for external uses. So that's why they mention are applied to living tissues such as wounds, cuts, and skin diseases in the form of antiseptic creams like furosemide and soframycin. Soframycin is a common example. Some important examples of antiseptics are Dettol, which we use at hospitals, at homes, and for different and in pandemics and all that. So Dettol is a mixture of chloroxylone and terifenol. So this is chloroxylone and this is terifenol. These are very important, the structures, because they may ask the structures, not the names. Bithionol is added to soaps to impart antiseptic properties to reduce the odors produced by bacterial decomposition of organic matter on the skin. So this is the structure of bithionol. ClCl, the benzene ring, and it's same on the both sides. Tincture of iodine is a 2 to 3% solution of iodine in alcohol, which is powerful antiseptic for wounds. The tincture is very common in hospitals. Iodoform CHI3 is also used as antiseptic for wounds. Boric acid is dilute aqueous solution, is weak antiseptic for eyes. So the disinfectants are nothing but the floor cleaners or the sprays which we are getting in the market. So these are the chemical substances which kill microorganisms but are not safe to be applied on the living tissues. They are generally used to kill the microorganisms present on intimate objects such as floors, drainage systems, instruments, etc. So in this category, there are surface disinfectors also. So some common examples of disinfectors are as follows. 1% phenol solution is disinfectant, while in lower concentration 0.2% solution of phenol is antiseptic. So the second point is 0.2 to 0.4 ppm aqueous solution of chlorine is used for sterilization of water to make it fit for drinking purpose. SO2 at very low concentrations behaves like disinfectant. Formaldehyde HCHO in the gaseous forms is used for disinfecting rooms and operation theaters in hospitals. The next is anti-fertility drugs. These are the chemical substances used to control the pregnancy. These are also called oral contraceptives. These they belong to the class of natural products known as steroids. Birth control pill essentially contains a mixture of synthetic estrogen and progesterone derivatives. Norethindrone is widely used as anti-fertility drug. So please remember norethindrone. They may ask example in any exam, any common entrance exams or any entrance exams. So the next topic is chemicals in food. Artificial sweetening agents, sucrose, tablet sugar. So generally old people use for the natural sweetening of anything. And fructose are the most widely and natural sweetness, but they add to our calorie intake and promote tooth decay. To avoid these problems, many people take artificial sweeteners. Organic substances which have been synthesized in lab are known to be many times sweeter than cane sugar. Such compounds are known as artificial sweetening agents or artificial sweeteners. Some important artificial sweeteners are given below. Saccharin, O-sulfobenzamide. So this is discovered by Johns Hopkins in 1879, University of USA. So This is the example: sodium salt of saccharic soluble in water. It is the most popular artificial sweetener. It is 550 times as sweet as cane sugar. Since it is insoluble in water, so it is a solid in the market as it's soluble sodium or calcium salt. It is non-biodegradable, so excreted from the body in urine, unchanged. Its use is of great value for diabetic persons and people who need control intake of calories. So, sorry guys, I may not explain the topics, but I'm just reading so that before exam, if you put earphones and just listen to this, you may strike some of the questions or the things which I'm reading, you may just strike in the exam. Aspartame is one of the artificial sweetening agent. It is a methyl ester of the dipeptide derived from phenylalanine, uh, phenylalanine, and sorry for the pronunciation, and aspartic acid. It is also known as NutraSweet. So the word is phenylalanine. Okay. It decomposes at baking or cooking temperatures and hence can be used only in cold food and soft drinks. I'm making this video especially for the people who don't have the book right now, who cannot purchase this book right now. Aspartame has the same amount of calories as sugar, 4 calories per gram. Aspartame should not be used by people suffering from genetic diseases known as PKU, ketone urea, because in such people decomposition of aspartame gives phenyl pyruvic acid. Accumulation of phenyl pyruvic acid is harmful especially to infants due to brain damage and mental retardation. So next is alitame. It is quite similar to aspartame but more stable than aspartame. It is 2000 times as sweet as sucrose. The main problem for such sweetener is the control of sweetness of the substance to which it is added because it is high potency sweetener. And the next is sucralose. It is trichloro derivatives of sucrose. Its appearance and taste are like sugar. It is stable at cooking temperature. It is almost 600 times as sweet as sucrose. However, it neither provides calories nor causes tooth decay. Cyclamate. It is N-cyclohexasulfamate. It is only 20 times sweeter than cane sugar. So this is the structure of cyclamate. The next topic is food preservatives. These are the chemical substances added to food to prevent their spoilage due to microbial growth, bacteria, yeasts, and molds, and to retain their nutritive value for longer periods. The most commonly used preservatives include table salt, sugar, vegetable oil, vinegar, citric acid, spice, and sodium benzoate. So I just want to give a small example, like vegetable oil, because after listening to this word vegetable oil, I first remember pickles and the salt. The salt and vegetable oil is used to preserve pickles for longer days, and yeah. And the sodium benzoate, the formula of sodium benzoate is C6H5COONA. Salt of sorbic acid and proponic acid are used as preservative for cheese, baked food, pickles, meat, and fish products. And the first one is sodium benzoate is metabolized by conversion into hypuric acid. The formula of hypuric acid is C6H5CO NHCH2COOH, which is ultimately excreted in urine. It is used in soft drinks and acidic foods. And the next one is antioxidants like BHT, butylated hydroxytoluene, and BHA, butylated hydroxynol, retarded the action of oxygen on the food and help in the preservation of food materials. So this is the structure of BHT, which is butylated hydroxytoluene, and BHA is butylated hydroxynol. So sorry for the pronunciation if it is wrong. Just Please don't worry. Cleansing agents. The word detergent means cleansing agent. Actually, detergent word is derived from Latin word detergere, means to wipe off. Cleansing agents are the substances which remove dirt and have cleansing action in water. These are also called surfactants. Detergents can be classified into two types: soapy detergents or soaps, and non soapy detergents or soapless soaps. And the first one is soaps. Soaps are sodium or potassium salts of higher fatty acids containing 15 to 18 carbon atoms. Example: stearic acid, oleic acid, and palmatic acid. Sodium salts of fatty acids are known as hard soaps, while the potassium salts of fatty acids are known as soft soaps. Hard soaps are prepared by cheaper oil and NaOH, while soft soaps are prepared by oil of good quality and KOH. The soft soaps do not contain free alkali, produce more lather, and are used as toilet soaps, shaving soaps, and shampoos. So, now preparation of soaps. Soaps containing sodium salts are formed by heating fat, glycerin ester of fatty acid with aqueous sodium hydroxide solution. The reaction is known as saponification. So this is the process of saponification. This is the fat which is converted into soap and glycerol due to heating. And this is one more example: oil, fat plus NaOH. Heating gives slope plus glycerol. The solution left after removing the soap contains glycerol, which can be discovered by fractional distillation. Sorry, this is recovered, not discovered. Sorry. To improve the quality of soaps, desired colors, perfumes, and medicinal chemical substances are added. Types of soaps. There are some kind of types of soaps. Different kinds of soaps are made by using different raw materials. Toilet soaps. These are prepared by using better grade of fat or oil, and care is taken to remove excess alkali. Color and perfumes are added to make these more attractive. Floating soaps. They can be prepared by beating tiny air bubbles into the product before it hardens. Transparent soaps. These are made by dissolving the soap in ethanol and then evaporating the excess solvent. Medicated soaps. Medicated soaps are prepared by adding some antiseptics like Dettol or Pithenol, so which are used like antiseptics. Shaving soaps. These contain glycerol to prevent rapid drying. A gum called rosin is added while making them. It forms sodium rosinate, which lather well. Laundry soaps. These contain fillers like sodium rosinate, sodium silicate, borax, and sodium carbonate. Soap chips. These are made by running a thin sheet of melted soap on a cool cylinder and scraping off the soaps in small broken pieces. Soap granules. These are dried miniature soap bubbles. Soap powder and souring soaps. These contain a souring agent, abrasive, such as powdered pumic or finely divided sand, and builders like sodium carbonate and trisodium phosphate. Builders make the soap act more quickly. Now, the disadvantages of soaps. Soap is a good cleansing agent and it is 100% biodegradable. This microorganisms present in sewage water can completely oxide soap to CO2. As a result, it does not create any pollution problem. However, soaps have two disadvantages. Soaps cannot be used in hard water since calcium and magnesium ions present in hard water produce curdy white precipitates of calcium and magnesium soaps. And examples are 2C17H35CONA plus CaCl. 2 is converted into, and the final product is 2NaCl. This is insoluble, so these are the two examples. Please note it down. These insoluble soaps separate as cum in water and causes hindrance to washing because the precipitate adheres into a fiber of cloth as gummy mass. Thus, a lot of soap is wasted if water is hard. And the second one is soaps cannot be used in acidic solutions since acids precipitate the insoluble free fatty acids which adhere to the fabrics and thus reduce the ability of soaps to remove oil and grease from fabrics. Soap is converted into free fatty acid, precipitate out. This is converted in last. The final product is Na plus. Soap plus soap. Synthetic detergents. The next topic in this book. Synthetic detergents have all the properties of soap, but actually it does not contain any soap. So they are known as soapless soaps. Straight chain alkyl group containing detergents are biodegradable, whereas branch chain alkyl group containing detergents are not biodegradable. Unlike soap, synthetic detergents can be used in both soft and hard water. Thus, this is due to the reason that calcium and magnesium salts of detergents, like their sodium salt, are also soluble in water. Synthetic detergents are mainly classified into three categories. So the three categories it is divided into, and the first category is anionic detergent. These are sodium salts of sulfonated long chain alcohols or hydrocarbons. Alkyl hydrogen sulfates formed by treating long chain alcohols with concentrated sulfuric acids are neutralized with alkali to form anionic detergent. So this is loudly alcohol, which is converted into lovely hydrogen sulfate, which is further converted to sodium loudly sulfate anionic detergent. And the second one is alkyl benzene sulfonates are obtained by neutralizing alkyl benzene sulfonic acids with alkyl dodecyl benzene, which is converted into dodecyl benzene sulfonic acid, and which is further converted into sodium dodecyl benzene sulfonate, and or we can call sod 4 1 dodecyl benzene sulfonate. In such in such detergents, the anionic part of the molecule is involved in the cleansing action. They are mostly used for household work and in toothpaste. And the last but not the least, yeah, two more categories. The second category is cationic detergent. These are quaternary ammonium salts of amines with acetates, chlorides, or bromides as anion. For example, cetrimethyl ammonium bromide. Sorry for the pronunciation. Uh, cetyletremethyl, cetyletremethyl ammonium bromide. I'm extremely sorry for the pronunciations. I don't have much time. Cationic detergents are used in hair conditioners. They have germicidal properties but are expensive, therefore, these are of limited use. Non ionic detergents. Such detergents does not contain any ion in their constitution. One such detergent can be obtained by reaction of stearic acid and polyethylene glycol, ethyl glycol, ethylene oxide, polyethylene glycol, polyethylene glycol stearate. So this is a reaction. Just note it down. And next we have liquid dishwashing detergents are non-ionic type. Mechanism of cleansing action of this type of detergents is the same as that of soaps. Advantages of synthetic detergents over soaps. Synthetic detergents can be used even in case of hard water, whereas soaps fail to do so. Synthetic detergents can be used in acidic medium while soaps cannot because of their hydrolysis to free acids. Synthetic detergents are more soluble in water and hence form better lather than soaps. Synthetic detergents have stronger cleansing action than soaps. Chemistry and coloring matter. The natural or synthetic coloring matter which are used in solution to stain materials, especially fabrics, are called dyes. All coloring substances are not dyes. Example, azobenzene, a colored substance, does not act as dye. A dye has following characteristics. It must have a suitable color. It can be fixed on the fabric either directly or with the help of mordant. It must be resistant to the action of water, acid, and alkalis. The groups responsible for color are called chromophore. Chromophore example. So this is the example of chromophore. The substance which do not give color itself but intensive intensify the color of chromophore are called oxochromo. Oxochromo, yeah. So this is the example of oxochromo. Classification of dyes on the basis of constitution: nitro or nitrose dye, chromophore NO2 or NO group, oxochromo OH group. Example: peric acid, Martius yellow, gambin, naphthol, naphthol yellow S. Azo dye. Example: Bismarck brown and methyl orange, methyl red, Congo red, etc. Anthraquinone dye. Alizarin. Indigo is the oldest known dye. Other examples are tyrene, purple, indigosol. And the next one is phthalate dye. Phenol, phthalate and fluorescent azoine, mercurochromo. These are the examples of this dye. Triaryl methane dye, malacet green rosinal. Okay, if the pronunciations are wrong, sorry for that, and just check out by yourself. Yeah, these are the examples. 1 2 3 4 total. And classification of dyes on the basis of application: direct dyes. These dyes apply directly to the fiber and are more useful to the fabrics containing H bonding like cotton, rayon, wool, silk and nylon. Example: Martius yellow, Congo red, etc. Acid dye. These are water soluble and contain polar acidic groups which interact with the basic group of fabric. Example: orange 1, Congo red, methyl orange, etc. These dyes does not have affinity for cotton but are used for silk, wool, etc. And the next one is basic dyes. These dyes contain basic groups like NH2 group and react with anionic sites present on the fabric. These are used to dye nylons and polyester. Example: butter yellow, magenta, rosinal, aniline yellow, etc. Watt dyes. Being water insoluble, these cannot be applied directly. These are first reduced to colorless soluble form by a reducing agent in large watts and then applied to fabrics. After applying, these are oxidized to insoluble colored form by exposure to air or some oxidizing agents. Example: indigo, tyrene, purple, etc. Modern dyes. These are applied with the help of binding material. Example: metanion, tannic acid or metal hydroxide called mordant. Depending upon the metal ion used, the same dye can give different colors. Alizarin is the important example of such dyes. In grain dye, these dyes are synthesized directly on the fabric. These are water insoluble and particularly suitable for cotton fibers. Azo dyes belong to this group of dyes. And the last dye, last but not the least dye, dispersi dye. These are applied to the fabric in the form of the dispersion in a soap solution in the presence of a stabilizing agent like cersol, phenol, benzoic acid, etc. These are used to color synthetic fabrics like nylon, orlon, polyesters and cellulose acetate. Anthraquinone dyes and monoazo dye are the examples of dispersed dye. And chemistry in cosmetics. Yeah, cosmetics are used for decorating, beautifying, or improving complexion of skin. Some of the cosmetics of daily use are, these are the daily use cosmetics. So first is creams. These are stable emulsions of oils or fats in water and contain, sorry for the pronunciation, emollients to prevent water loss and humectants to attract water as two fundamental. These are the two fundamental components which are present in cream. And next comes perfumes. The solutions of pleasant odor and invariable consist of three ingredients: a vehicle, ethanol plus H2O, fixative, example sandalwood oil, benzoin, glycerol, diacetate, etc., and odor producing substance. Example, terpenoids like linalool, anisaldehyde, sorry for the pronunciation, anisaldehyde, p-methoxybenzaldehyde, etc. The third one is talcum powder. It is used to reduce irritation of skin. Talc, Mg3OH2, Si4O10, chalk, ZNO. Zinc stearate and a suitable perfume are constituents of talcum powder. And deodorants. The difference between perfumes and deodorants is nothing but the perfumes is used on the cloth which you are wearing, and deodorants is directly applied to body. These are applied to mask the body odor. These possess antibacterial properties. Aluminium salts, ZNO, ZNO2, C17H35COO2, ZN can be used in deodorant preparation. And rocket propellants. Substances used for launching rockets are called rocket propellants. These are the combination of an oxidizer and a fuel. Depending upon the physical states of oxidizer and fuels, rocket propellants are classified as. So first one is solid propellants. These are further divided into two classes. Composite propellants. In these propellants, fuel is polymeric binders such as polyurethane or polybutadiene, and oxidizer is ammonium perchlorate or potassium perchlorate. And the last page of this chapter, and the second one is the double base propellants. Yeah, these mainly use nitroglycerin liquid and nitrocellulose solid. The nitrocellulose gels in nitroglycerin sets in as a solid mass. And the second one is liquid propellants, oxidizer, N2O2, N2O4, sorry, N2O4, liquid O2, HNO3, and fuel, kerosene, alcohol, hydrogen or liquid hydrogen. These are the two types. Monopropellants. In such propellants, the substances act as fuel as well as oxidizer. So some of the examples of monopropellants: CH3NO2, H2O2, CH3ONO2, etc. Biliquid propellant, fuels, kerosene, alcohol, etc., and oxidizer, liquid O2, liquid N2O4 or HNO3. And the last topic of this chapter, hybrid propellants. In these, solid fuel and liquid oxidizer is used. Example, acrylic rubber, solid fuel, and liquid N2O4, liquid oxidizer. SLV3, space launch vehicle 3, and SLV, augmented space launch vehicle. The Indian satellites used composite solid propellants in space shuttle. Liquid O2 plus liquid H2 is used. So this is the end of the chapter of chemistry in everyday life. So please apologize for wrong pronunciations, and if you like this video, and if you like this video, for the next video I'll try to improve my pronunciations and the reading style and the video quality. Thank you for watching this video until the end. So all the best for everyone for the preparations of JEE, mains, advance, and NEET, MSET. And this is a video for the people who don't have this chemistry Arihant handbook. It includes keynote, terms, definitions, formulas, and it is very useful for quick revision purpose, and it's cost around 275. And thank you for your support, and thank you for your patience to listen the chapter. Hope you like this video. If you like this video, please encourage me to take next video. So I first started this video on theory based chapter, so next I may make a video on request of the followers, subscribers, which chapter they want. And thank you. Have a good day.